Alright, so today is day 19. I'm gonna show exactly what I did. At the beginning, in the morning, was mostly watching videos about LLMs. I'm following the lectures I was talking about. Today, it was mostly about a mixture of experts. I will do a summary later when I have a bit more time, but I'm gonna show exactly what was practical today. And we're trying to build I'm trying to build right now the GPT tokenizer. In order to do that, I'm building a tokenizer. And the tokenizer that I'm building is using the byte pair encoding algorithm. In order to build the byte pair encoding algorithm, we need basically two parts. One, we need to give in a list of characters. We need to convert these characters into numbers. But once we have this, we need to count the frequency of how many pairs, what is the top most frequent pair. And secondly, we need to be able to merge those pairs into a new character and being able to track this into the vocabulary. So at the beginning, we're going to have 256 characters. And at each iteration, we're going to merge. What would be a good example? Okay, I'm going to just give a quick example. Yeah, if we have this string, AAABAABAC, I can, right now the vocabulary size, because we only have A, B, and C, is of 3. And the length of this, so I'm gonna show it, length text, oh my god. Right now the length is of 9 elements, alright? And the vocabulary size, vocab, is of 3 elements, okay? So what we do with byte pair encoding is that we take this list and say, for example, the most repeating pair, it's AB. It is repeated 1 and twice. No, actually, AA is repeated more. 1, 2, 3. Yeah. I mean, it's essentially the same, but it takes the most repeated pair and it changes the vocabulary size to be 4 because you replace the pair as a new character, but in exchange you decrease the length of the text. That's it. That's like the intuition. And in order to construct this is dividing the algorithm into parts. First, identifying the most frequent pair given a list. And we can do it with this. We can create a dictionary called counter, and every time it finds, basically it initializes an empty counter and add as a key the 2 elements in the first, let's say, 2 consecutive elements in the list, and iterate over all possible pairs. If it doesn't exist, and every time that it do this query to the counter, it's going to increase 1. That's it. And this is an example. Given this sequence, we can count AA is found 3 times, etc. So this is the intuition of the algorithm. First the frequency pairs, and then the merging. We do this, the frequency pairs, and this we do this for the merging. And the intuition of the merging is, if we have this sequence, for example, 5, 6, 6, 7, 9, 1, and we find that the most repeated pair is, for example, 6, 7, we have to find a way to find the sequence and replace this by the next character in the vocabulary, which, let's say here is 99. So we want to take this and put a 99. So this is the example, and we want to do this for all instances of this pair. So how do we do it? I mean, we create a list, in this case it's called new IDs, and we iterate over the list. So we iterate over the list. At the beginning, the index is 0, and we increase it, and we check if the first 2 numbers that I'm checking, if this number is equal than this and this is equal than this, then I have a match and I have to merge. And it's not technically merging, but is rather copying the two matches into a new list. So if these two make sense, I'm copying it and I'm adding it into the list and moving to, because I merged two elements. Otherwise, I'm just gonna, if it's not a match, I'm just gonna add the element as it is. That's the merging. And then, now that we divide the problem into two subproblems, we found the solution of those two subproblems, we can combine them to give the final algorithm, which is basically this. Given an amount of merges, we call stats to get the dictionary of frequencies of merges. We can get the single most frequent one, and we can merge. I mean, we have to update the index of the vocabulary. It's going to be one more every time. So we update the index and we pass this into the merge function that will take the list and will return another list that it's smaller in size but bigger in one more vocabulary. So with this we do 20 merges, and this decreases a lot the size of the merges, because every new potential merge that you do, every new merge that you do is a new potential for the next one. And this, for example, after 20 merges, we got from 24,000, which was the length of the initial text, to 1919, which is a reduction of 1.3. And that was it. Today was just it, implementing this algorithm. And let's continue.